This is section 6, Deployment with Docker. In this section, we're going to take a look at what is Docker and its basic concepts, how to write Docker files, Docker networking and data management, using Docker Compose, monitoring Docker containers with Prometheus, and what is service discovery. This is video 1, Introduction to Docker. In this video, we're going to take a look at what are Docker images and what are Docker containers, working with Docker, Dockerizing a Go application, the basic options of using a Dockerfile, and how to customize the creation of a container with Docker run parameters. So let's look at container basics. Containers run on a host, which is running on OS, and they share the kernel with the host and also with other containers. So if you have various containers running on a machine, they will all be sharing the same host kernel. But containers are isolated from each other and from programs running on the host. Though you can expose certain ports, for example, you can communicate from one container to another through a post or maybe through a network, but if they run on their own, they're isolated from each other. Containers are very lightweight because they are not virtual machines. The main difference between a virtual machine and a container is that a virtual machine has its own kernel, and a container uses the host kernel. The two main concepts of Docker and Docker images and containers. Docker images are immutable files that are a snapshot of a container. They are created with the build command and they need to have a Docker file to have the parameters of how to build the image. When started with run, they produce a container. So from one image, you can produce various containers. Images can be created locally, so you can have a registry of images on your local machine, but they can also be published in a Docker registry. The main Docker registry, the default Docker registry, is Docker Hub, and in Docker Hub you will find all sort of images for all kind of applications. The one, for example, all the ones we have been using, like Nginx, MariaDB, and Redis, they have all been downloaded from Docker Hub. And so what are containers? Containers are lightweight and portable encapsulations of an environment in which to run applications. Throughout the course, we have already been using Docker a lot. So the first thing we're going to do is to list all images. To that, we do Docker images. This lists all the images we have been using. I have a lot of them. For example, here we have Mongo. The tag is the version of the image we are using. The first line here, the repository, is the name. The image ID is the ID of the images. Here we have when it was created and the size of the image. Well, you can see we have Postgres, MariaDB, Prometheus, Redis, etc. Now, to look at all the running containers, we do sudo docker ps. I have just restarted my computer, so I don't have any Docker container running. To list all of the containers we have in our machine, you do ps-a. Here we have all the containers that we have on the computer. We also have the ID, the image name, the name of the container, the command that was used to start a container, when it was created, and the status. They're all exited. To start a container, all we have to do is docker start and the name of the container. For example, we're going to start Postgres. It is running, and now if you do sudo docker ps, it will show. Yes, it shows that Postgres is running. We can also use a stop and restart. We're going to stop the container. And we have stopped the container. So how do we create images? To create images, we use Docker files. And what are Docker files? Docker files are templates from which an image will be generated. Docker builds the image automatically by reading instructions from a Docker file. A Docker file is a text file that contains some commands in order needed to build a given image. So let's look at an example. We're going to Dockerize the sample application we have on example 1 of the video. The application basically is just, it's similar to the one we use with Nginx. It just starts on port 8080 and it has a handle function that basically returns home when we connect to the endpoint, just shows the number of requests it had received. Now let's look at the Dockerfile. Well, let's look at, these are the commands we have on the Dockerfile. The first one is from, which is the parent image that we're going to use when creating this image. All Docker images start from a parent image. In this case, we're going to start from Golang 1.10. Then we're going to run a command which will create the directory slash app. Then we're going to add a file called main slash app and add it to app slash app slash main. And then we're going to run the command slash app slash main. So basically we're creating a directory, we're copying a file to the directory, and then the command is, we are running that command of that file on the image. So what was our main file that we are adding to the application? Basically, what we're going to do is we're going to compile the main.go application. It's a very simple app. The name we're going to get for the target executable is main. We do that by doing go build, and we are setting up the environment that we're compiling to be Linux, because well, Docker runs on Linux mostly. And so we'll do that. After we have done that, we have the executable file, which is here, main. And we can now build our application. So to build our application, we run docker build. T is the example that we're going to use. In this case, it's the name we are going to use for the Docker image, which is going to be example, and the tag is going to be 1. And we are building it from the Docker file we have on this current directory. So there it goes. It does all of the steps on the Docker file. It starts from Golang 1.10, then it runs and creates make dir, then it adds the file, then it does command dot, and then it builds the example, and it targeted example 1. We have built the image, so now we can start a container from that image. What we're going to do is we're going to do sudo docker run. The name of our container is going to be example container 1. We're going to expose port 8080 and on 8080, and this is the image that we're going to be using. So this is, we have started the image on foreground mode. This means that everything that goes to standard out on the image is going to get to standard out on our terminal. If we now go to 8080 on our machine, port 8080, we're going to get it's running, and we can also see the requests that were done. Since we enter through Google, it not only do our pass, but it also asks for the favicon.ico. But well, let's stop the image, the container. I'm sorry, the image is stored. Let's store the container. There it is. And now, if we want to remove a container, the first thing we need to do is to stop it, and then we can do sudo docker rm. We're going to remove this container because it was an example and there's nothing really interesting there. Sudo docker rm example container 1. The container was removed. And if we want to remove an image, we do sudo docker rmi, which is remove image. And in this example, we have sudo docker rmi example 1. So we have deleted our image. So let's look at our Dockerfile commands. Remember that we build an image from a Dockerfile. The first one is from, which will be the starting image. It's the image that we're going to start our new image from. For example, it could be an operating system, or in this case, we're using Golang, Golang image. Runs a command during the image build. It can be used to create a directory. It can be used to change the permissions on a file, stuff like that. Command runs software containing the image along with any arguments it has. This is basically the command that's going to run when we start the container. In the example we had before, we were running main. Expose is a port in the container, meaning that that port on the container will be available from the outside world. Then we have environment key value, which adds an environment variable. We could have a list of key values that will have the form m key equals value, key 2 equals value 2. And then we have copy, which can sync, copies files. Add is exactly the same as copy, but can use URLs as sources and can sometimes be used to decompress a file when we have it on the. If we can add a file, if it's compressed, it will decompress it. And well, there's some other Dockerfile commands, but these are the main ones. So let's look at our second example. On our second example, on the main.go, it's the same application as before. The only thing is we're taking the port that the application will be running on from an environment variable that we're calling application port. And on the Docker file, we are setting that application port to be 7951. So when we build this application, it will set that environment variable. When main runs, it will get that environment variable and set the port based on that environment variable. The other thing we're doing, we're exposing that port. And the other thing that's important is we're using Golang 1.10, the image Alpine image. Alpine image are tightly controlled and they're small in size. So you can build very, very small images, but they have a couple of little interesting things. The first thing we're going to do is we're going to build the executable file. Since we're going to use Alpine, and Alpine doesn't have all of the libraries that a general Ubuntu or general Linux distribution has, it's very, very small. We're going to build it with CGO enabled to false so that it doesn't use dynamic libraries when it builds, and it's all one big static file. We do that. It's done. And then we're going to build the new image that we're going to call example2. Now we're going to create a container. We're going to start a container with local run from that image. We're going to start it on the background, which means that we'll continue running and it will free our terminal. We're starting from example2, and we're exposing port 7951 to 8080. So now when we connect to 8080, it will pass to 7951 on our container. So let's see, we're connecting to 8080, but here it says we're receiving it on 7951. So remember that when we run Docker run on an image, we actually create a container from that image. Let's look at the basic options. Name, we'll set up the container name. If you don't specify a name, Docker will create one for you, but they are kind of weird, so you should always specify a name. -D starts as in detached mode, so if you close the terminal, it will still be running. You can set a restart policy for the container, for example, restart always, which will always restart if it fails. Or you can have it restart on failure only 10 times. -E creates an environment variable for that container and that container only. That's different than setting up an environment variable on the image, which will be available to all containers you create from that image. And also you can expose ports with -P, and it has two values. The first value is the one we're going to be using from the outside, and the second value is the one on the container. Apart from that, you can set up runtime constraints on the container. For example, the amount of memory it should be using, the amount of how much CPU it can use, etc. There's a link on the README for all of those options. There are a lot, and well, if you want to check them out, check them out. This only works if you're running various containers on one host. If you're running only one container on one host, you shouldn't touch this because it will automatically use all the resources the host has. Another important command when working with containers is docker inspect. We're going to run sudo docker inspect and the name of our container, which is example container 2, which is the one we have just started. And it will show us all of the parameters of how the container is running. I suggest you actually, when you test this, that you actually look at inspect. We're going to be using it next video, but as you can see, it shows all of the parameters of the container. To finish, let's look at some recommendations when using containers. First one is always use official images. If you're going to be using, I don't know, Redis or MySQL or whatever, always use the official image. If you're not using an official image, if you're using an image that has been created by somebody else, that it's on the Docker Hub, please take a very close look at the Dockerfile to see how it was created. because there have been malicious use of Docker images where they had malicious of code on those images. So make sure that you know where you're starting your Docker files from, and also your new images from, and what images you're using. Apart from that, create ephemeral containers. The containers should be as simple as possible. And apart from that, decouple applications. Don't run on a same container your database and your cache and your application at the same time. Use different containers for each of these parts of your application.